Alrighty, dun dun dun. Day 2 of falling objects, projectile motion, story problems. Today we're going to work on finding the time when it lands on the ground or at some other height. So we're going to keep working on that, but we're going to add another piece to it. We're going to talk about finding the maximum height. To get to the maximum height, it is the vertex of the parabola. Okay, and remember the vertex is the point where the parabola crosses itself on the axis of symmetry. So a lot of our problems, it's going to start at the bottom and then go up to some maximum height and then come back down. So again, we're going to be finding that vertex. Now, there is a formula that you do need to know to find that vertex. Well, first, real quick, the vertex is going to be an xy coordinate. To find the x-coordinate, it is going to be negative b over 2a. Okay, that right there will help us find the x-coordinate. Once we find the x-coordinate, we're going to use the quadratic function, ax squared plus bx plus c. We're going to substitute our value of x into the function to solve for y. Okay, and that's how we'll get that. So let's go ahead and get started with our first example. Example number 1. We have a football is kicked from a starting height of 3 feet with an initial upward velocity of 40 feet per second. Use the vertical motion formula. H equals negative 16 t squared plus vt plus c, where h is height, okay? V is velocity, c is the starting height, t is time to land. Okay, so real quick, what I want to point out, that x corresponds to t of time, and y is equivalent to or corresponds with our h of height. Okay, and you'll see that with all of our projectile motion problems. Okay, let's go ahead and do part A. Part A says complete the equation by substituting the appropriate information. So t, we're going to go ahead and start with just recapping the function. So 0 is equal to negative 16 t squared plus 40 t plus 3. Now to find when t is 0, we're going to substitute 0 in for t. And when I substitute 0 in for t, I get 3. Then we're going to substitute 1 in for t. Okay, I'm going to pull out my calculator here real quick. When I do this, it's going to be negative 16 because I have 1 in for t. 1 squared is 1 plus 40 because 40 times 1 is 1 plus 3, we get 27. Then I'm going to put 2 in for t. Okay, when I do this in the calculator, and I'm okay if you do this, every time you have an operation in between the plus signs, you need to make sure you have parentheses around that. So that's going to be negative 16 times 2 squared, and parentheses, plus, and then parentheses 40 times 2, and parentheses, plus 3. Okay, and that gives us 19. Let's go ahead and plot these points on our graph. And so, real quick with the graph, it says height h is dependent on the t time, graph t on the x-axis, height on the y-axis, and that's what we labeled up here, okay? And then again, use non-negative values for t because t is time, t can't be negative. So to find the maximum height of a football, whenever we're finding maximum height, we are solving for vertex. Okay, so I'm going to use that formula, x equals negative b over 2a, and I'm going to make my substitutions. So b is 40, so it'll be negative 40 over 2 times a is negative 16. And then again, we can just do this in the calculator, where I'll have negative 40 divided by, and then since I have an operation at the bottom, I want to make sure I have that in parentheses. 2 times negative 16, we get 1 1/4. Now that's the x-coordinate. Now we have to find the y-coordinate. To find the y-coordinate, I'm going to substitute 1 1/4 in for t in the equation that they give us. So negative 16 times 1 1/4 squared plus 40 times 1 1/4 plus 3. Then we're going to go ahead and do this in the calculator. Again, in the calculator, we'll do negative 16 times 1 1/4 squared. That gives me negative 25 plus 40 times 1 1/4, 50 plus 3. I add that up, and then I get 28. Okay? Now, remember, y corresponds to height, and here it even tells us that it is going to be feet. So 28 feet. And I now realize I forgot to plot the points on the graph, but we'll do that here at the end because we're going to add this vertex into the graph as well, but we'll finish B and C and then we can backtrack. So part C says, how long does it take the football to reach its maximum height? Now, if you remember, X corresponds to our time, okay? T as in time. So my answer here is going to be 1 and 2500th seconds. So again, the vertex is the maximum height. It happens at 28 feet, and it happens after 1 1/4 seconds. Okay, now taking my graph and my maximum height, let's plot it into this coordinate plane here. So when x is 0, height is 3. When x is 1, we have 27. 2 at 19. And then can't forget our vertex. So vertex is 1 1/4 at 28 feet. Then connect your dots. And I'm going to have it line go all the way down at some point close to the bottom because I know the football will hit the ground eventually. Okay? Let's go ahead and try the second one on this as well. So problem number 2. So problem number 2, we have an apple is launched directly upward at 64 feet per second from a platform 80 feet high. The equation of this apple's height at time seconds after launch is h equals negative 16t squared plus 64t plus 80. Part A says find the maximum height. That is my vertex. Okay, to find vertex, we're going to use those steps that we did before on problem number 1. So we're going to start with the formula. I'm using t instead of x because I see t in the formula. T equals negative b over 2a. That's the formula. When I make my substitutions, it's going to be negative 64 over 2 times negative 16. When I simplify, I get 2. Then that's my x coordinate, okay, for the vertex. To find the height, h, okay, I'm going to use the function. Now that I know that I have a value for t, I'm going to make my substitution. So negative 16 times 2 squared plus 64 times 2 plus 80. Okay, and then we simplify. So same thing in the calculator, negative 16 times 2 squared, we get negative 64. 64 times 2 is 128, and we drop down 80. We add this all up, and we get 144 feet. So that is going to be my maximum height. That is the y coordinate of the vertex. So again, if I wanted to write my vertex as an ordered pair, it would be 2, 144. But I'm only focusing on the height part of it. It'll be at 2 seconds, but just the height part. So part B says, how many seconds will it take for the apple to reach the ground? Now this is from yesterday, okay? So this is where we need to set our height first, and we'll go ahead and set it equal to 0. We're solving for t this time. When it says how many seconds, we're solving for t. T is my unknown, so my value for h is going to be 0 because h is at the ground. So when I make my substitutions, I'm going to put 0 in for h. I have negative 16t squared plus 64t plus 80. Okay, and then I start simplifying. Now, when I say I start simplifying, I'm going to start by seeing if I can factor easily. But I see I do have a GCF, so I drop down that 0. 16 goes into all three, and I'm going to factor out a negative 16. The reason I'm going to factor out a negative 16, well, negative divided by negative, I now work with a positive t squared. That's what I'm used to working with. That's what we're used to working with a positive ax value, so that's what we're going to maintain. So 64t divided by negative 16, that gives me a negative 4t. 80 divided by negative 16 is negative 5. Keep factor by solving. Keep solving by factoring. That came out backwards. This is a trinomial, so factors of negative 5, that would add to negative 4. That'll be t plus 1, t minus 5. Now I'm going to set each factor equal to 0. And then solve for t. And so when I solve for t, what I have is t equals negative 1. Well, time can't be negative, so my answer that I'm going to go with is t equals 5. And so the question is how many seconds? It's going to be 5 seconds. Okay, so that's it for this one, and then we'll practice the rest next time I see you in class.